So let's go ahead and illustrate this. I'm going to go ahead and start with the first two problems from the handout, sample hypothesis test problems for homework assignment 8, part 1. So these will be the first type. The type where you test a claim about a population percentage by following the 6 steps that are given on pages 545 and 546 of the cheat sheet, which is under the p-value method, which is a 6-step flow chart. So, go ahead and get your handout out because I stated the questions and I've got the answers. So, let's look at example problem 1 from the handout. Handout over sample problems, chapter 23, or homework assignment 8. Example problem 1. The first thing you want to do, of course, we're going to be using the flow chart that's on pages 545, 546. That's the 6-step method we're going to use. But in step 1, the first thing you want to do is you want to read the given claim in English. And you have to translate that claim into what's called symbolic language. So let's read example problem 1. It says in example problem 1, suppose a certain government agency claims that the percentage of job applicants in the U.S. that had a drug test component associated to their interview process over the past year that failed the drug test portion of that interview was less than 5.8%. So they're claiming that less than 5.8% of all job applicants who had a drug test component to that job application failed that drug test component. So that's the claim. Now, if you were going to do a census to test this claim, you would have to survey or find a way to get the exact answer for every job applicant in the U.S. last year that had a drug test component and find out from each one of them whether they passed or did not pass. That's just not practical. The reason why we use inferential methods is because in most cases it's not practical to conduct a census to either get a population percentage or to test a claim about a population percentage. So you always have to resort to inferential methods, which is to test this claim by getting a sample of all job applicants that had a drug test component from the previous year, and from the sample, determine just from the sample of applicants how many of those applicants failed their drug test. And then you'll have to use that sample proportion together with the steps in the flow chart to determine whether your sample statistics from your sample are supporting or not supporting the claim that's being given here. And the way you want to write the claim is you have to always start off, I'm going to put step 1, but the first part of step 1 is writing the claim in symbolic language. If you're testing a claim about a population percentage in symbolic language, you have to translate the verbal information about the claim into the form P. P standing for population proportion. Inequality sign, P0. P means population proportion. So you need to write population proportion, inequality sign, and then P0 will always be some number between 0 and 1 because it's a proportion. Now, if we read what it says, we don't care about the category so much as the population proportion here is the proportion of all job applicants last year in the United States that had a drug test component and failed the drug test component. We're claiming that proportion, we're claiming that as a percentage, that percentage is, it says, less than 5.8%. Now, usually given information is in terms of percentages, and we'll write our final answer that way, but for the test statistics and things we're going to use, we want to convert all percentages into proportions. So saying that the percentage of job applicants that had a drug test component, that failed their drug test component, is less than 5.8%, is the same as saying the proportion is less than, you have to move the decimal place 2 places to the left and say the proportion is less than 0.058. So saying percentage less than 5.8% is the same as saying the proportion is less than 0.058. So writing this in symbolic language in terms of proportions, you'd have to put P is less than, because it says fewer than or less than. You know, words like fewer than or less than turn into a less than inequality sign, and then of course the P naught would be in this case 0.058, which is a number between 0 and 1. So this is the claim written in symbolic language. Once you have the claim in symbolic language, let me make sure this is coming up in the video, then you need to write what's called the counterclaim in symbolic language. The counterclaim is actually what we're testing in a hypothesis test. Or not exactly the counterclaim, but something that's going to come from the counterclaim. And when you want to write the counterclaim in symbolic language, it's like the complementary claim. It's the only other possibility if the claim is false. So we only have two possibilities. Either the proportion for the relative category is less than 0.058, and if the proportion is not less than 0.058, what's the only other possibility? The only other possibility is that P had to be what? Greater than or equal to 0.058. Now, in all the claims and all the problems of both types, the inequality sign in her book is never containing what's called the condition of equality. Meaning all the claims in all of her problems either have a less than sign or a greater than sign. You're either saying a percentage is less than some number, or the claim is that a percentage is greater than some number. So you never get an equal sign in the inequality sign for claims in hers. Now, in general, out of the other book, claims could have equal signs in them or not have equal signs in them. But for all of the ones that are in her book, none of the claims have equal signs. So that means the counterclaim will have an equal sign. If the claim has a less than sign, the counterclaim has to have a greater than or equal sign. Because either the proportion is strictly less than 0.058, or what? The proportion is greater than or equal to 0.058. So if the claim doesn't have an equal sign in its inequality sign, the counterclaim has to have an equal sign. Now, if the inequality sign had been a greater than sign here, then the counterclaim would have been less than or equal. So the claim won't have an equal sign in this book, and the counterclaim will. And the counterclaim she refers to as the baseline claim. Okay. All right, so in step one, you first write the claim that's given in English, written verbally. You have to translate that verbal information given in the claim into a simple symbolic language statement like this. Proportion, population proportion, inequality sign P naught. Once you have that, then you write the complementary or counterclaim also in symbolic language. P inequality sign P naught, same P naught. Only difference is you write the complementary inequality sign. So you get a symbolic statement for the claim, you get a symbolic statement for the counterclaim. Now what happens is the one with the equal sign gets converted into what's called the null hypothesis. And that, in this case, it will always be the counterclaim in this book. So the one that has the equal sign becomes the null hypothesis. And you write it as H sub 0. And it isn't written the same way as the counterclaim. What you do is, for the counterclaim, or the one with the equal sign, you replace the inequality sign with an equal sign. So when you write H naught, which comes from the counterclaim, you're going to write it with an equal sign. You're going to put P equals P naught. And in this case, P naught is the 0.058. And then you're going to put what's called the alternative hypothesis, H sub 1. Make sure this is coming in the video. And H sub 1 is the notation in the flowchart on page 545 for what's called the alternative hypothesis. And this is always going to come from the claim in this book. It's the one that did not have the equal sign, and you just copy it just like it's written for the claim. So H1, which comes from the claim, is P less than 0.058. So from the given claim, you extract the symbolic language for the claim, the symbolic language for the counterclaim. The counterclaim is converted into the null hypothesis with the inequality sign replaced by an equal sign. The claim is written as is as H1, the alternative hypothesis. So you convert claim and counterclaim into null hypothesis and alternative hypothesis. We're then going to spend the rest of this testing the null hypothesis, which comes from the counterclaim. And based on our results of that test, we'll decide whether we have information to support or not support the alternative or the claim. Now, the last thing you need to do to complete step 1, because we're still on step 1, is once you get the null and alternative hypothesis written in symbolic language, you need to decide whether it's a left-tailed test or a right-tailed test. And the way, if you look on page 545, it tells you if the inequality sign from H1 is a less than sign, it's left-tailed. So we have a less than sign in the claim, which means a less than sign in the alternative hypothesis. If you have a less than inequality sign for H1, then you say it's a left-tailed test. Now, if the inequality sign from H1 had been a greater than symbol, then we would have a right-tailed test, and that's illustrated in step 1 of the flowchart. We have a less than symbol, we're left-tailed for this test. So that completes step 1. I'm going to go ahead and erase this now so we can go to step 2. For example, problem 1. All of this is, if you're following along, it's all printed here. So all these calculations, everything I'm writing on the board is already printed in detail in this handout. So you just need to follow along. You don't have to actually write it down. Now, when you get to step 2, if you look on page 545, step 2, it says, determine a significance level. Let's see what it says. Read it exactly. It says, determine a significance level that will minimize a type 1 error. Or let's see what it says. It says, select a level of significance alpha depending on the seriousness of making a type 1 error. It turns out that in every one of the problems in the homework, and from any book I've ever used, they've already selected that significance level. It's already part of the given problem. If you just read example problem 1, you'll notice that given in that problem, they already given you a significance level they call alpha. And in this particular problem, it says, first use the flowchart on page 545-46 for the p-value method to determine whether or not there is sufficient statistical evidence to support this claim based on a significance level, it says, of alpha equals 0.01. So they always give you the significance level as alpha in the problem. All you have to do in step 2 is write down the given significance level that's in the problem. You don't have to determine it. You just have to read it in the given information and write it down. This is just like the confidence level that's given in a confidence interval problem from chapters 20 and 21. Significance level of 0.01 is the same as confidence level of 99%. The only other significance level you're going to see is 0.05, and 0.05 significance level has the same meaning as confidence level 95% in the chapter 20 and 21 problems. We just write them this way, so 95% confidence and 0.05 significance have the same meaning. 99% confidence and 0.01 significance have the same meaning. They're just two different ways of giving that same information. And the reason why you have significance levels and confidence levels is because it's an inferential study. It's the same explanation we gave for confidence interval problems. Now we go to step 3. If you read step 3 of the flowchart, step 3 says, this is the part that changes from one flowchart to the next. This is where you get your test statistic. Now, to get the test statistic, you have to read the given statistical information we got from the sample that we're using to test this claim. The test statistic from the cheat sheet, if you go back to, it says in step 3, it gives the formula. And it calls it Z0 because we're going to treat it like a Z-score. It says in the flowchart, Z0 equals P hat, P upper hat, that's what I call it, which is sample proportion. It's the same notation we use for sample proportion in the confidence interval problems in chapter 2021. Same notation, p hat. Minus p naught. Remember, p naught was the number that came from the claim. It's the right-hand number in symbolic language for both h naught and h1.